This is part 23, preparation for NSE4 exam, Fortinet. Today we will talk about IPsec VPN. What is IPsec? IPsec joins remote hosts and networks together into one private network. Usually, IPsec VPN provides authentication, data integrity, so it has HMAC tamper proofing. HMAC is a key hash message authentication code or hash-based message authentication code. IPsec VPN also provides data confidentiality, encryption. Multiple protocols that work together as authentication header provides integrity but not encryption. Is defined in the RFC, but FortiGate doesn't use it. If required, set a custom port for both IKE and IKEnet, initiator and responder. Protocol IKE, Internet Key Exchange, RFC 2409 with net traversal uses IP protocol 17, UDP port 500 or UDP port 4500 for rekey. RFC 4306 also uses that for net traversal. But if there is no net, it uses IP protocol 17, UDP port 500. Protocol ESP with NAT traversal uses IP protocol 17, UDP port 4500, encapsulated. The same for RFC 4303. If there is no net traversal, it uses IP protocol 50. To configure a custom port for using command line interface, we use command config system settings, set IKE port and then choose port, then put end. Custom port range is from 1024 to 65,535. FortiGate always listens on UDP port 4500. It's for responder only. To set up VPN, you must configure matching settings on both ends of the VPN, where VPN is between two FortiGate devices, or FortiGate and FortiClient, or a third-party device and FortiGate. If settings don't match, the tunnel setup fails. Note: FortiGate always listens for port UDP 4500, regardless of the custom port settings. How does IPsec work? First, encapsulation. Other protocols are wrapped inside IPsec. Varieties by mode. What is inside? Transparent mode for TCP or UDP, tunnel mode, additional IP layer than TCP and UDP. IPsec includes negotiation for authentication and handshake to exchange keys and settings. Transport mode of IPsec directly encapsulates and protects the fourth layer, which is transport layer of OSI model, and all above layers up to application. The original IP header is not protected and no additional IP header is added. Tunnel mode is a true tunnel. The whole IP packet is encapsulated and the new header is added at the beginning. After the IPsec packet reaches the remote LAN and is unwrapped, the original packet can continue the journey. Note that after we remove the VPN-related headers, transport mode packet cannot be transmitted any further. It has no IP header inside, so it's not routable. For that reason, this mode is only for end-to-end or client-to-client VPNs. So the structure of the IPsec, first there is original IP header and then there is TCP or UDP data. There could be tunnel mode. In tunnel mode, there is a new header front, then ESP header, then original IP header, then TCP or UDP SCTP. Then at the end there will be ESP trailer and ESP integrity check. All part from ESP header up to ESP trailer is authenticated, and the part from original IP header up to TCP, UDP, up to ESP trailer is encrypted. And in transport mode, structure of the packet is the first original IP header, then ESP header, then TCP, UDP, SCTP data, then ESP trailer, and at the end ESP integrity. And the part from ESP header to ESP integrity is all authenticated, and part from TCP UDP up to ESP trailer is encrypted. Internet Key Exchange, IKEv or IKE, used to authenticate peers, to exchange keys, and to negotiate the encryption and checksums that will be used. Essentially, it is the IKEv control channel. ESP is encapsulated security payload. ESP is encrypted payload. For data channel. Internet Key Exchange. Default ports for IPsec Internet Key Exchange are UDP port 500 and UDP port 4500 when crossing NAT, Network Address Translation. Internet Key Exchange negotiates a tunnel's private keys, authentication and encryption. Internet Key Exchange has two phases, Phase 1 and Phase 2. And IKE also has two versions, IKE version 1 and IKE version 2. Let's talk about comparison between versions 1 and versions 2. As for exchange models, for IKE version 1, main is total messages, there are 9. 6 messages for phase 1 and 3 messages for phase 2. And there is aggressive for IKE1. Total messages are 6, 3 messages for phase 1 and 3 messages for phase 2. And in IKE version 2, one each procedure only. Total messages are only 4. As for authentication methods, for IKE Internet Key Exchange version 1, they are symmetric. Certificate signature, pre-shared key, PSK. Extended authentication is XAuth. XAuth is not standard method of authentication. And as for version Internet Key Exchange version 2, authentication method for IKE2 is asymmetric. There is certificate signature and pre-shared key, PSK, and it uses EAP pass-through authentication protocol. As for NAT traversal, for IKE version 1, it's supported as an extension. And for IKE version 2, NAT traversal is native support. As for feature reliability, IKE version 1 is unreliable. Messages are not acknowledged. And for IKE version 2, feature reliability is reliable. Messages are acknowledged. Dial-up remote access for phase 1 matching ID. For IKE version 1, peer ID plus aggressive mode plus pre-shared key. Peer ID plus main mode and plus certificate signature. For dial-up version 2, IKE version 2 has peer ID and network ID. Traffic selector narrowing. In IKE version 1, traffic selector narrowing is not supported. It is supported only in IKE version 2. Negotiation, security association. Security Association has abbreviation SA. IKE allows the parties involved in a transaction to set up the security associations, SAs. Security associations are the basis for building security functions into IPsec. In normal two-way traffic, the exchange is secured by a pair of security associations. IPsec admins decide the encryption and authentication algorithms can be used in the exchange. IKE, Internet Key Exchange, uses two different phases. Phase 1, outcome IKE SA. Phase 2, outcome is IPsec Certificate Authority, IPsec Security Association. Thank you.